Hey, what is up, guys? Welcome to Software Engineering Channel. This is Karthik. So I've been doing a multi-part video series. In these video series, I'm building a network library from the scratch. Um, as I'm programming, I'm explaining what is the reason behind some of the decision that I'm making. What are the benefit that I think it would yield in the long term. That's the format. So there is nothing scripted here, as I said in my previous video. So this video could go long or short. I do not know. So I'm gonna continue to record until we accomplish what we set out to accomplish in the video. That's the format. So far we have implemented three use cases. These three use cases. In our previous videos. So if you have not got a chance to watch my previous video, I strongly recommend it because this video will not make any sense until you watch the previous video. At least if you can just skim through it, and if you check out my GitHub repository where I have uploaded this code, at least just get familiarized with this code base. Otherwise, this video definitely will not make sense, right? So I will add the link somewhere. I still have not figured out how to do that in YouTube. Maybe this video is going to be a nice opportunity for me to, add the link, info link somewhere. Anyway, so in this video, what we are going to do? So we are going to do a code cleanup. In my previous video, I have implemented a couple of public protocols, couple of areas that I feel like that we need some rework. So we're going to do that cleanup here. And then second, we're going to see if we can improve the code coverage to 100%, right? That's what we're going to do. So let's see what we could do. So as always, this this is just a simple package, nothing fancy about it. Let's recap what we have here right now. We have the builder. This is the public facing API for the consumer. So the consumer is going to make use of this builder to create an instant of network service. This network service is a internal class. We are not going to expose this class to the consumers. The consumers are going to be receiving the network requesting protocol. This protocol is a simple protocol that has only one purpose. It is going to send a request and then return back a combined publisher. The user can wait for the response. That's it. So that's how the consumers are going to communicate with the library. So we have a receiver in between. This receiver is going to take in the request and then forward the request to a platform class. The platform class is the platform abstraction for URL response. URL session. We added that as a means to switch the network stack. For example, right now we are using URL session. Maybe if we find a better alternative, and who knows, a socket connection, who knows, a different library that implements a networking logic in a different way, we can just switch it if we abstract the abstract the platform implementation. So that's how it is done. So to summarize, this is how it is happening, right? We have a network, we have a builder. There it has a build method. This build method is going to create a network service. This network service is going to talk to network request. Come on. The network request receiver is going to send that request to platform, which is URL session for now. That is what this network platform is marking. So one thing that I'm starting to think, the more I think about this network request receiver, the more I'm feeling like we don't need that entity, right? All this guy does is just forward this request to a platform. This is just an additional entity, and also I have declared this as a public protocol, but there is no way for the consumer to make use of it or configure it. It's of no use. It's just an intermediate level. It's just something that I wanted to improve. Let's see what we can do about that, right? Um, okay. What if I just copy this guy, um, uh, and then put it directly, right? So what I'm gonna do here is I'm gonna remove this entity. That's what I'm gonna do, right? Let's remove this. Okay. If that is the case, then I can just directly add this guy over here, and instead of sending the platform here to the service receiver, I can just add the platforms right over here in the network service. So if that is the case, the network service can directly talk to platform and then get the um, perform request for request. Oh, also another thing that I wanted to improve. Network platform. This is redundant. It's perform request. Okay, perform request. This is something that another thing that I wanted to do. Sorry. Perform this request. But yeah, I don't know. Maybe we could just call it perform. And for now, let's keep a perform request. Or execute request would be a execute request would be a better name. Perform request or execute request. Okay. Anyway, yeah. So we are directly communicating with this person. Then if that is the case, we don't need this entity, but let's update this one. The builder needs to update itself. So the builder need to be updated. Right now we're directly instantiating network service. We don't need the return keyword as Swift. A return statement is implicit if there is only one line inside the method. So that is good. Let's build this thing and then see if it has any trouble. Oh no. You know what? Why don't we just delete it? We're not using it anywhere. Oh, sorry, build it. Build fail. That is because of the mock session. Oh yeah, so we have to update that. We have a mock session that implements the network protocol. So we have updated the method name to execute, right? Execute request. Nice. Okay, so it is building network, and then let's see if the test is running. The test ran, and then we have a 90.5. Previously we had 91. Other net, look at this is Xcode cache. Anyway, let's clean and then build it. Yeah. Okay, 90.5. Previously it was 91, but anyway, so 100 in all the other places. We have a network platform that, okay, this method is not at all reached. That is expected because we did not add any instrumentation test. So we're not making an actual API call, so we need to write an instrumentation test for this one. Okay, so let's see. So this is good. So this is one thing that I wanted to do. And also, why don't I introduce a new folder called modules, 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 and this API, the network request and response, these two folks can go over there. All right, so making sure it builds. Good. Okay, it builds. Okay, so now the next thing that we wanted to do is to see if we can improve the code coverage for this one so that we can get 100% code coverage. Let's see. Why don't we just introduce a new folder here? It is called, what am I doing here? Okay. Hopefully this is recording. Okay. Nothing changes because I pressed a couple of keyboard shortcuts. Hopefully that doesn't mess up the recording. Network instrumentation tests. Okay, let's copy that name. Go to our package and then introduce another test target. Why don't we just copy paste this guy? All right, we're going to depend on the network target. That is fine. Save it so that Xcode will prepare our package for it. So this is what is that? Okay, so nothing under this location, so we're gonna add it. Why don't we just add a new test file, network test, same as the unit test, because we're going to, that's what we're going to test. Why don't we just copy paste our one of our test. Yeah, just let's copy paste all the thing for now, because I'll show you what's the beauty of it. This, see, we have a network request sent to the server, receive response. Why don't we just use this thing? We're gonna implement a test called a test very similar test. Well, in fact, it's the same test that we have written in unit test, but this time we're going to make a actual API call. The test that we are going to copy is, given a network service, when a response is received from server, then the response is returned to the consumer, right? The same test as unit test, but let's see how best we can modify this. I'll show you. Okay, so we have the mock platform. We're going to delete that. I'm doing all this modification in instrumentation test. Let's close all the other files so that it is not confusing. Okay, so if you notice that we are not mocking anything here, we're just directly building. This is how the consumers are going to use in their production code. So if that is a production code, then I'm going to directly use URL session. Why don't I declare it? Okay. Let's use shared session. So this time we're going to make an actual API call. There is no expected data here. We don't need to test that. Response is received is enough, good enough. Okay. Add a value. No need for that. I'm just stripping down all the unnecessary things. Why don't, since it is since this test is going to make an actual API call, we need to wait. So we're gonna create exception. Expectation with the description, network call, successful network call. All right. So before I assert it, I'm going to wait it. Usual stuff. This time I am going to do a 2-second. This is another thing that I wanted to talk. Okay, let's go to our success criteria before. So in our success criteria, we said all the unit test has to be executed synchronously. If not, The maximum runtime of the test is 200 milliseconds. Some cases we cannot avoid a synchronous task. So in those places, we only wanted to limit our test execution to 200 milliseconds. But what if it is a instrumentation test, right? So if it is instrumentation test, then has to be run within 2 seconds, right? That is the goal. So this is the another goal that we should have already added, but previously we were not thinking about instrumentation test. Now anyway, so this is a good addition. Let's add that. That is the reason why I'm adding this 2 seconds. Let's have that here. Okay, what else we need to update? Okay, if we receive an error, then we're gonna say, okay, we are not expecting an error. XCT failure 0. Okay, wait a minute. Error dot localized description. So it's failed. If it is success, then we don't need to test the response data. All we need to do is to just test, okay, whatever if we are receiving the response properly. That is more than enough for this test. Okay, good. Everything is good. So we have, okay. All right, sounds good. So let's see let's build this thing. Oh, mock platform. We don't need mock platform. Okay, we don't have, we don't have that error because the utilities that we have added, it is added somewhere over here, right? We cannot access that. So let's for now, let's write, you know what? Let's Okay, let's do that next. Yeah, that would give me an opportunity to introduce another section in this video. Let's do the sync here. Completion. When you receive value. Okay. Case failure. Okay. If it is an error, then we're gonna success expectation fulfill immediately. We don't need to wait no more. Okay. Okay. This is working. We don't need to store the response. This does not need to be a mutable property. This is going to fail, right? Correct. This is going to fail because this is not an actual endpoint. So we're going to create an endpoint. So before this video, so I have created a mock URL using this mock URL, manage my mock. You see, this mock URL is going to just return as a message. HTTP, it's a application type is JSON. Yeah, sorry, return type is JSON. It's going to return 200, just a simple message. So I am going to copy this URL. So I'm going to make use of it. In your day-to-day work, you don't do this, right? I'm doing this because I'm lazy to create a simple node server or something. Usually when we do in our product, in our CI, we usually create a simple node server because node is easy to create. We create this node server before the CI start the test. We're going to kickstart this local node server in the CI machine. So this node server is going to just support all the needs for our instrumentation test. That's all this node server does. That's how we usually do it. But in this video, I'm going to make use of this mock server. There's this solution available in our in internet. We can just make use of it this for this purpose. Again, guys, this is not again is the way that you do. Just write your own simple node servers. There are a couple of tutorials and videos available how to do it. So okay, anyway, let's send this thing and then see if this works. It's running. Okay, amazing. Okay, so now this instrumentation executes successfully. Okay, what's going on? API violation, multiple calls to accept. Okay, maybe I'm doing something wrong here. Oh, there you go. Um, okay, testing. Nice. That is good. Let's see if our execution reaches the platform. Nice, right? So it has reached. So it has reached, it has executed here. So now let's see what is our test coverage. 100%. Nice, right? There you go. So we were able to do 90, 91, 90 percentage in our unit test. There one specific method that our execution was not reaching. Then we have written a instrumentation test that just reaches the execution, that specific corner of our code. There you go. So we were able to achieve 100% code coverage within our success criteria. So we have all the success criteria that we have defined. We are not violating any of. We are not failing any of our success criteria. Everything is good. Good, good. Okay. So let's see if we can just refactor this one. So right now we are just using a sync. I don't want it to do that because we already have a utility method we have declared that is called that has a method called on value start with bag. I would like to make use of that utility here as well. Let's see if we can just clean up this code. Again, this is a blue face. I think it's a blue face. I keep saying that blue face. I think I'm right. Yeah, this is the blue face of our test-driven development. This is where we just do our cleanup. Okay, let's see what we can do. We wanted to share this guy among these two targets, test targets. Why don't we declare another test target? Sorry, another target called utilities. Wait, hold on. Why am I utilities? Correct. All right, utility. All right. Anyway, well, before I write this utility, I would wanted to take a time and then talk a little bit about the term utility. I am not. I'm not all for writing a utility class like arbitrary utility, right? You will see a lot of in a lot of project folks have engineers have have created. Well, let me rephrase that sentence. In your project, usually you will see a model called or library called utilities. That is something that I'm not okay about it because the utility, it does not convey anything anything to the consumer, right? It's just like a sounds like a dump. It does not convey any what is the purpose of the library. What ended up happening is that since it's vague, engineers ended up dumping all their reusable code in that one single model. So it became as like a, it's like a, yeah, as the dump is a correct word, dump for everything. So that's not correct. So that violates a principle called common closure principle. What the common closure principle states is that, in an essence, it is a single responsibility principle for a component level. A component should only change for one purpose or one theme of purpose. It should only contain files and classes that is relevant and organized around one single theme or a purpose, right? So if we put, for example, combined related utilities here, and then at the same time, if we need I don't know, UI kit related utilities here at the same time, then these two are not relevant no more. Then that violates common closure principle. So now, if that is the case, then we need to go a little bit granular from that utilities, and we need to create a utilities that is going to contain files of one single purpose, right? So now we are adding a network test utilities that is specifically designed for network testing purpose, right? It's gonna only contain utility files that is going to be helping our network test. um, Maybe we can call it a combined utility or something like that, but since we are only using that in a network test, I'm going to call it network test utility, more specific. Sometimes you will get a pushback from your team that, oh, we don't want it to have a granular library, or how granular we can go. Some have in the past, I have had a pushback from the team that, oh, if we do a granular, are we going to have a library that has only one or two files? How many files are allowed? Some people will come and then say, hey, maybe a 5 files, a 10 files. Some people say, hey, it's okay to have a granular, but it becomes as a opinion battle, right? We don't want to put ourselves in that um, way of approaching granularity. What we wanted to do is, this is what we wanted to put ourselves in. We are going to adhere to the component principle, because the modularization is not a unique problem to any particular project. The modularization um, is a problem that exists ever since the software, ever since we started writing software, and then the solution already exists for those problems, right? All we have to do is to follow the component principle, and we're going to accept the outcome of following the component principle. If the component outcome of the component principle is producing a few granular libraries, then we're going to take it. That is the best outcome that we're going to have by following a granular component principle. If we ended up producing few granular library in our project, that is the best possible outcome that we're gonna get. So that is how we wanted to put ourselves in. These granular libraries, they are not going to be granular for prolonged time in our project. As the project grows, as the team grows, as the use cases grows, as the feature grows, engineers are gonna add more and more to this granular library, and then it's not going to be granular. So we are setting a stage for our project in a way that in the future, even in the future, engineers will not violate this component principle. That is what we are setting. We're setting a really good stage, right? That is how we want to approach. Instead of talking about how granular is acceptable or not, that is going to be opinion battle. So we don't want to engage that. All right. So that is a reason why I do all this purpose driven. That is the reason why I modularize our code base uh, with a with the purpose driven libraries, right? Anyway, that's that. Let's move our code here. So we have a new target called network test utility. Let's go there and then create a new folder, network test utility, clean up it. Okay, so this guy gonna contain one single file. Let's delete this folder, we don't need that. Hopefully this is still recording. Okay, yeah, still recording. I just have to check it once in a while. That's why I'm just, viewing this side because I have another monitor. It has OBS. And just make sure that it is recording. There are a few times I have recorded a couple of things, then it's not recording. I feel like, oh man, come on. So I just want to make sure. Okay, anyway, so this target have one file. So now this is not a this this file resides in a separate target. We need to make sure this is accessible to other targets. So I'm going to mark it as public. This so now this method is going to be accessible. Uh, Good. So let's see if there is any error. Okay, good. So Swift compiler, Swift package is happy. Look, can you guys see this thing? It just keeps switching. I hate this when it happens. Anyway, let's see. Let's go. Since we have a new thing here, we're gonna say, okay, I'm gonna do that. This is gonna contain two target. The test targets are gonna depend on these two folks, these two new targets. Okay, if that is the case, then we're gonna have to import. This should not compile if I understand correctly. There you go, it doesn't compile. It doesn't compile because it do not know what is the meaning for this symbol, meaning for that method. Yeah, it couldn't find that method, right? Yeah. Now let's see. Good, now it's compiling. So let's go here and then say on error. Oh, wait, let's import it. All right. On error, do this one. On value, do this one. Okay, now we can just delete this guy and start with bag. We already copied the bag there. So yeah, anyway, it's there. We're gonna wait for 2 seconds. Test utilities. You know what? Why don't I just declare a new constant for this one? Runtime. Runtime. Is runtime a single word? I think maybe it's a single word. Anyway, it doesn't matter. Is it a single word? Oh yeah, it's a single word. Yeah. Anyway, it's good. Let's do this. Copy this file name and then put it out here in the header. Just annoying, isn't it? Instrumentation test runtime. Instrumentation test runtime. Okay. 2 seconds. Let's put it out here. This will give me a nice little dot operator. I really like this way of doing because I like to declare the property there. So yeah, anyway. Okay, this is good. What else? Let's run it. Cancel. Oh yeah. So since we are using bag, we don't have to explicitly do a bag. You know what? While I'm at it, why don't I just move this bag here? Every time when we run a before a test executes, we're gonna get the setup method executed. So here I'm going to create a bag so that if the bag has something, it's going to be cleared. If that is the case, you know what? Even in our unit test, we can do the same thing. Let's do that. Okay, sounds good. Let's build this and compile. Let's run the test. Yeah, it's running the test. And okay, 100. Yeah, sounds good. So this, guys, come on, this is really good. I really like it. uh Look at this. This is 100% code coverage, right? So this is unit 100%. So all the files that we have is 100% good coverage. And uh, we have not violated any design pattern. Sorry, we have not violated any principle, component principle or a design principle here. We have achieved a stable library because we have built a stable library. Well, we are building, it's not completed. So far it is stable since we don't have any external dependency. All the APIs are abstract. In my previous videos, I have not talked about, I have talked a little bit about abstract, the purpose of it, but I wanted to add a little bit on that topic. Previously, I have mentioned having an abstract API for a library, it helps at the helps the feature model to market. That is true, but there is one more thing also. There is a principle called a stable abstraction principle. It states that it's a library is as stable as it abstract, right? What that means is that uh, if you wanted to add more behavior to this library in the future, once we implement and ship this thing, if you wanted to add more behavior or functionality to this library, you don't want to edit the existing class. You wanted to add the behavior without modifying your existing code base. Naturally, that means we are talking about open close principle. Yeah, that's what it mean by, right? So a class has to be open for extension and closed for the modification, something like that. Anyway, so if that is the case, how are we going to add new behavior? So if we have the public APIs abstract, we can make use of a principal design pattern called decorator pattern. You know what? Why didn't I add it? Stable abstraction, right? So we can make use of a decorator pattern and create a new class in our library. See, for right now, we have only one class called network service. In the future, what we could do is if we wanted to add a behavior, we can just add a um, XYZ network service, and this service can be like network service class, right? We can create a decorator, and this one also can be a network request receiving. Since it's the decorator, we're gonna have a underlying service. We can take in our existing service. This is just pseudocode. This is how we are going to use the network. We are going to use the decorator pattern to extend the library. So this is the beauty why we wanted to write a abstract public API. Oh, service, right? Let underlying service equal to underlying service. Um, okay, so this is good. Um, okay, so this is good, right? So now this guy has to implement um, send. Now this guy has to implement this send method, and this we can just call the underlying service start send. Wait, hold on. Request receiving. This shouldn't be there. Oh yeah. Oh, okay. So we have not deleted it. Okay, you know what? We should have deleted this one. This is not necessary. Network requesting. Yeah, that should have gone. Yeah. So we can just send the request, right? So if you notice that this is still talking with the abstract protocol. Uh, so now in this send method, we can write our additional logic here. Maybe if condition, if we wanted to have a additional logic, otherwise just if the request is of our new behavior, then we can just add additional logic. If it is not, then we can just fall back to our original logics. So this way, if you notice that we are adding a new behavior to this library, but at the same time we are not modifying our existing class, right? So this is only possible if our public APIs are abstract. So this adheres to open close principle cleanly. Yeah, that's what the stable abstraction principle talks about. Yeah, this is one of the technique. I just wanted to add more to this abstract public API. Okay, let's delete this guy. No, we don't need it. Deleted. Okay. All right. So that's what I'm talking about. So we have a stable. So far, we have a stable library. All the APIs are abstract. 90% code coverage. We have achieved 100%. All the unit tests are synchronous. All the instrumentation tests are less than 2 seconds. Good, good. This is really good. Okay, this is what I wanted to accomplish in our in this video. Just let me run this test finally one more time to make sure I have not messed up anything with the pseudocode. Sounds good because we have deleted a file as well. Sounds good. Okay, everything is 100%. That's it, guys. Oh my God, it's dark outside. I'm sorry about that. My dog is messing with my headset. Sorry about the background noise. It's getting dark outside. I'm gonna have to color correct my video here. Anyway, thank you very much for watching. So we will. I will talk to you guys in the next video. Okay. Thank you for watching.